Hi everyone, today I'll solve the questions in the past paper IGCSE Mathematics 0580 in October-November 2023, and this is question paper 41. Question 1. A. Describe fully the single transformation that maps shape A onto shape B. So we will take two corresponding points on shape A and shape B. For example, I choose these two red points. And I see that I need to move 1, 2, 3, 4, 5, 6, 7 units to the left. 7 to the left, which means -7 for x. And 1 unit down, which means -1 for y. So the transformation is translation by the vector -7, -1. Second question, shape A onto shape C. From A to C, it is a rotation. And to describe a rotation, we need three things. Rotation. First, we need to know the center. Second, the angle, how many degrees. And lastly, the direction. Is it clockwise or anti-clockwise? So let's find the center first. In this case, I will choose two blue corresponding points on A and C at the right angle. And to translate from A to C, the center should be around here because this line and this line are perpendicular to each other. And from A to C, we need to move like this. So that is clockwise direction. This is clockwise. And the angle is 90 degrees. And the center is 5, 1. So we'll write down the answer. The center is 5, 1. The angle is 90 degrees. Clockwise. B. On the grid, draw the image of shape A after a reflection in the line y equals 2. So we'll draw the line y equals 2 first. This is the line y equals 2. And now we draw the reflection of A over this line. From A to this line, we see that there are 1, 2, 3, and 4 units. So we continue to move on 1, 2, 3, and 4 units. So the image of A will be here. I'll remove the lines. So we see that the image of A will be here. This is the reflection of shape A in the line y equals 2. Next, this is the first question. Second question, draw the image of shape A after an enlargement. Scale factor -2, center 0. You know that the scale factor is equal to image over the origin. And if it is -2, this means two things. First, the image will be twice of the origin. Next, the image and the origin will be in the opposite direction. Opposite directions. So, keep this in mind, and we plot the point 0, 0. This is the point 0, 0. This is the center of the enlargement. And we will check the distance from the center to the triangle A. For example, this one, 2 units. So we need to move on the opposite direction and we need to double it this. So this is 1, 2, 3, and 4 units. Then the image of that point is here. Next, this one, 3 units. So we continue to move on 3 and 6 units. So the image of the blue point is here. And finally, this one, 4 units. So we'll move on 1, 2, 3, 4, 5, 6, 7, 8. So the image will be here. And the final answer for that is, I will use this one. This is the image of the shape A after an enlargement. Scale factor -2, center 00. And that's it. Question 2a. S equals 1/2 AT squared. Find the value of S when A equals 9.8 and T is equal to 20. So we substitute everything into the expression and S is equal to 1960. B. Solve this equation. You can expand the brackets. 5 times 4y equals 20y. 5 times 3 is 15 and then equals 15. Now we need to add 15 to both sides. So 15 plus 15 is 30. Finally, we divide both sides by 20. 30 divided by 20 is equal to 3/2, or we say 1.5. C. Expand and simplify. 3 times 5 is 15x. 3 times -8 is -24. -2 times 3x is -6x. -2 times -7 is +14. 15x minus 6x is 9x. And -24 plus 14 is -10. So the final answer is 9x minus 10. D. Arrange A equals 2b squared minus 3c cubed to make C the subject. To make C the subject, I need to remove 2b squared by subtracting both sides. I will subtract 2b squared from both sides. So this is -3c cubed. And to make C the subject, we need to remove the number -3. So I will divide both sides by -3. And that is C cubed. Finally, to make C the subject, we need to remove the cube, which means we take the cube root of both sides. So this is A minus 2b squared over -3. Or you can also write your answer like this. The cube root of 2b squared minus A over 3. These two answers are the same. Cube root 2b squared minus A over 3. A. Factorize completely. For the first pair, the common factor is 2q, and 6pq divided by 2q equals 3p. -4q divided by 2q is 2. For the second pair, we just write minus and then 3p minus 2 is left in the brackets. Now the new common factor is 3p minus 2 and 2q minus 1 is left. So that's how we factorize it. 3p minus 2 multiplied by 2q minus 1. Question 3. A. The table shows information about some of the planets in the solar system. 1. The average distance. Notice that the average distance from the Sun in kilometers. And this is the diameter in kilometers. And this is the name of the planets. 1. The average distance of Mars from the Sun is 2.279 times 10 to the power of 8 kilometers. Write this distance in as an ordinary number. So we see that this is 2.279. If we multiply by 10 to the power of 8, which means we move this decimal point 8 places to the right. So let's move it 1, 2, 3, 4, 5, 6, 7, 8. So we'll stop here. And we'll fill in the zeros. So we need to add 0, 0, 0, 0, and 0 here. So the final answer is 2,279. And then we add 5 more zeros. Second question. The planet Uranus has a diameter that is 35.8% of the diameter of the Jupiter. The diameter of the Jupiter is here, 143,000. So if Uranus is 35.8% of that, so we multiply 35.8% by 143,000 to find the diameter of the Uranus. And the answer for this is 51,200 kilometers. The third question, the ratio diameter of Neptune to diameter of Saturn can be written in the form 1 to n. So we need to focus on Neptune and Saturn. And then we write it in the form 1 to n. So let's check the table, Neptune and Saturn. Neptune is here. We are talking about the diameter, and Saturn is here. So we need to compare 49,500 and 120,500. 49,500 divided by 120,500. And this fraction is 99. We simplify it and we get 99 over 241. And this is in the form 1 to n. So we need to find the value of n. Then n, we need to find the inverse of 99 over 241. So I flip this. And n is equal to 2.43. 2.43. Fourth question. Find the average distance of Neptune. Average distance of Neptune from the Sun as the percentage of the average distance of the Earth from the Sun. So in this case, we compare Neptune and the Earth. And we need to look at the column of the average distance. So let's check Neptune and Earth. Neptune, the average distance from the Sun is this. And for the Earth, the average distance is this one. So we compare these two numbers. We find the average distance of Neptune as the percentage of the Earth. So question 4. Neptune is 4.495 times 10 to the power of 9 over 1.496 times 10 to the power of 8. And we need to find this as the percentage. So I will multiply this by 100%. Let's rewrite it. 4.495 times 10 to the power of 9 over 1.496 times 10 to the power of 8, and we multiply by 100%. So this one is equal to 3000%. The fifth question. Distances within the solar system are also measured in astronomical units, AU. The average distance of Jupiter from the Sun is 5.20 AU. Calculate the average distance of Mars from the Sun. So we are talking about average distance of Jupiter, 5.20 AU. And we need to find the average distance of Mars. So in this case, we compare the Jupiter and the Mars. Let's check it. Average distance, Jupiter, this one, and Mars, this one. We know that the average distance of Jupiter is 5.20 AU. This one is 5.20 AU. And we want to know the Mars is how many AU. So let's write it again. Jupiter. The average distance is 7.786 times 10 to the power of 8 kilometers is equal to 5.20 AU. And then for the Mars, it's 2.279 times 10 to the power of 8 kilometers. So this one is how many AU? To find this, we multiply 2.279 by 5.20. Then we divide this by 7.786 times 10 to the power of 8. This one also multiplied by 10 to the power of 8. So the answer for this is 1.5052 AU. The next question, the diameter of Mars. I will use the blue. The diameter of Mars is 39.2% greater than the diameter of Mercury. Calculate the diameter of Mercury. So when we see the structure, something is 39.2% greater than Mercury, then remember the Mercury will be 100%. And then the diameter of Mars will be 139.2% because it is greater. So let's write this Mercury 100%. And we add 39.2% to get the Mars, which is 139.2%. In the question, we know the diameter of Mars, here it is 6,800. So Mars is 6,800 kilometers for the diameter. So we find the Mercury. Then we need to divide 6,800 by 139.2 to find the value of 1%. And then we multiply 1% by 100 to find the value of 100%. So this one is equal to 4,890. B. 1 light year is the distance that light travels in 1 year of 365.25 days. The speed of the light is 2.9979 times 10 to the power 5 kilometers per second. Show that 1 light year is 9.461 times 10 to the power 12 kilometers. Correct to 4 significant figures. So, first of all, we see that the speed is in kilometers per second. And the time here is days. So we need to convert 365.25 days into seconds. You know that each day has 24 hours. Each hour has 60 minutes. and each minute has 60 seconds. So we multiply these together and we get 3,155,600 seconds. So this is the time. And we know that the speed is 2.9979 times 10 to the power of 5 kilometers per second. So to find the distance, according to the DST triangle, the distance is equal to speed multiplied by time. So we multiply 2.9979 times 10 to the power of 5 by 3,155,600 together. So this one is equal to 9.460652904 times 10 to the power of 12. And when we want to round it to 4 significant figures, then it is 9.461 times 10 to the power of 12. 9.461 times 10 to the power of 12. Here we go. Second question. The distance from Andromeda galaxy to Earth is 2.40 times 10 to the power of 19 kilometers. Calculate the time taken for light to travel from this galaxy to Earth. Give your answer in millions of years. In this case, we know the distance. This is the distance. And we also know the speed of light. So we need to find the time. The speed of the time is, according to question B, the speed of time is 2.9979 times 10 to the power of 5 kilometers per second. And this is the distance. So according to the ST triangle, the time is equal to distance divided by speed. The distance is 2.40 times 10 to the power of 19, and we divide it by the speed. The speed is 2.9979 times 10 to the power of 5. So this one is equal to 8.0056 times 10 to the power of 13 seconds. But the question asks you to give your answer in millions of years. You know that 1 year is equal to, here we go, 1 year is 3,155,600 seconds. So if we have 8.0056 times 10 to the power of 13 seconds, then it is corresponding to how many years? So we need to divide 8.0056 times 10 to the power of 13 by 3,155,600. And the answer is 2,536,823 years. And we want to write it in million of years, so I will move the decimal point 1, 2, 3, 4, 5, 6. So it's 2.53683 millions of years. Or if you round it to 3 significant figures, it is 2.54 millions of years. Question 4a. Lucia has 2 fair spinners. Spinner A is 5-sided and is numbered from 1 to 5. Spinner B is 9-sided and is numbered 333, 4444, 455. Lucia spins the 2 spinners and records whether they land on a prime number. So we need to focus on the prime numbers. In spinner A, the prime numbers are 2, 3, and 5. In spinner B, the prime numbers are 3 and 5. So 1. Complete the tree diagram. In spinner A, there are 3 out of 5 numbers are prime. So the probability of prime numbers is 3/5, and the probability of the number that is not prime is 2/5. Similarly, in spinner B, there are 5 out of 9 numbers are prime, and 4 out of 9 numbers are not prime. So we fill in the blanks. 5 nines and 4 nines. Second question. Find the probability that the 2 numbers are both prime. I want both prime. So the first number is prime and the second number is also prime, which means we multiply 3/5 and 5 nines. 3 out of 5 multiplied by 5 out of 9. So this is 3 nines, and we simplify it to 1/3. B. The 2 numbers are not both prime. Do you see that this is the opposite of question A? So the probability of this will be 1 minus 1/3 equals 2/3. B. Lucia spins spinner A 120 times. Find the expected numbers of times the spinners land on a prime number. In question A, you see that the probability of the prime number for spinner A is 3/5. And if you spin it 120 times, then it is 3/5 multiplied by 120. So the answer is 72 times. C. Lucia spins spinner B twice. Now we spin it twice. Find the probability that the 2 numbers lands on add up to 9 or more. Remember, the spinners B has the numbers like 3, 3, 3, 4, 4, 4, 4, and 5, 5. So if you want 2 numbers add up to 9 or more, then it can be 4 plus 5, 5 plus 4, or 5 plus 5. So let's talk about the probability of 4, 5, and then we add the probability of 5, 4. And finally, we add the probability of 5 and 5. To get 4, we see that there are 4 numbers. 4 numbers out of 9 numbers. And to get a 5, it is 2 out of 9. Similarly for this, the probability of 5 is 2 out of 9. The probability of 4 is 4 out of 9. And thus, 2 out of 9 times 2 out of 9. So the answer for this is 20 over 81. Question D. Lucia keeps spinning spinner B until it lands on a 4. Find an expression in terms of n for the probability that this happens on the nth spin. On the nth spin, Lucia lands on a 4, which means for the nth time, she got a 4, which means for n minus 1 times, she does not get a 4. And you know the probability of not getting a 4 is 5 out of 9. And the probability of getting a 4 is 4 out of 9. because the spinner B has 9 numbers and there are 4 numbers more. So this is 5 out of 9 n minus 1 times, so to the power of n minus 1 multiplied by 4 ninths. And this will be the final answer. 5 ninths n minus 1 times 4 ninths. Question 5a. ACD is a right angle triangle. B is on AC and BC is 54.5 meters. AD is 83.2 meters and angle ABD is 38 degrees. Calculate the angle ACD. ACD is this red angle. To find this angle, we see that AD is the opposite to that angle. And we also need to find the length of AB because AB is the adjacent of the angle C. So in this case, we need to use tau, which means tan of C is equal to opposite AD over adjacent AC. AD is 83.2 meters and AC is equal to AB plus BC. BC is 54.5 meters. And that's why we need to find the length of AB. So now we'll focus on the length of AB. In the triangle ABD, AB is the adjacent to the angle 38 degrees and 83.2 is still the opposite. So once again, we apply the tan of ABD is equal to opposite AD over adjacent AB. So it's 83.2 over AB. And the angle ABD is actually 38 degrees. So from this, we know that AB is equal to 83.2 divided by tan 38 degrees. So now we'll substitute this AB into the second expression. So it's gonna be 83.2 over AB is 83.2 over tan 38 degrees. And we add 54.5. So tan C will be this, and to find the angle C, we need to use the inverse of tan, the inverse of everything. 83.2 over 83.2 over tan 38 plus 54.5. And the answer is 27.3 degrees. B. EFG is a right-angled triangle. A circle can be drawn that passes through the 3 vertices of the triangle. On the diagram, mark the position of the center of the circle with a cross. Explain how you decide. If this circle can pass through these 3 points and the angle E is a right angle, then it means the center must be the midpoint of FG. The center must be the midpoint of FG. The reason is that because the angle in a semicircle is 90 degrees. Angle FEG in a semicircle is 90 degrees, which means we form a semicircle like this. C. In triangle LMN, the ratio of angle L to M to N is 4 to 5 to 6, 4 to 5 to 6. In triangle PQR, PQ is 6 centimeters, PR is 4 centimeters, and QR is 5 centimeters. Calculate the difference. We want to find the difference between the largest angle in PQR and the largest angle in LMN. In the triangle PQR, we see that the angle R is opposite to 6 centimeters, and 6 centimeters is the longest side, so R is the largest angle. So I will try to find this angle R. We will use the cos rule. The cos rule says that PQ squared is equal to RP squared plus RQ squared minus 2 times RP times RQ multiplied by cos of R. So let's substitute the number. PQ is 6 equals 4 squared plus 5 squared minus 2 times 4 times 5 times cos R. So 6 squared is 36. 4 squared is 16. 16 plus 25 is 41. Minus 2 times 4 is 8. 8 times 5 is 40. 40 cos R. So we can find negative 40 cos R by subtracting both sides. Subtract 41 from both sides. So this is negative 5 equals negative 40 cos R. This means cos of R is equal to negative 5 over negative 40 equals 1/8. And then R is equal to the inverse of 1/8, which is 82.8 degrees. This is the largest angle in triangle PQR. And now let's find the largest angle in the triangle LMN. In LMN, 4 plus 5 plus 6 is 15 units. 4 plus 5 plus 6 is 15 units. And these three angles add up to 180 degrees. The total is 180 degrees. This is the sum of angles in a triangle. So the angle, we know that the largest angle in LMN is the angle N. The angle N is corresponding to 6 units. And we want to know this one is how many degrees. So first we divide 180 by 15 to find the value of 1 unit. Then we multiply it by 6. So it's gonna be 72 degrees. This is the largest angle in triangle LMN. Angle N. Now, to talk about the difference, we will subtract 72 from 82.8. So the answer is 10.8 degrees. 10.8 degrees. Question 6a. We need to complete the table for the 3 sequences. The first sequence, 7 plus 4 is negative 3. Negative 3 plus 4 is 1. 1 plus 4 is 5. So 5 plus 4 is 9. The fifth term is 9. And to find the nth term, we see that the common difference is 4. So You know the general form of a linear sequence is an plus b. A is the common difference, and b is t0. This is t1, t2, t3, t4, t5. So t0 means which number plus 4 equals 7. That number is negative 11. So B is t0, which is negative 11. And A is 4, so the answer is 4 and minus 11. Sequence B, 7, 13, 23, and 37. First, we'll check the first difference. 7 plus 6 is 13. 13 plus 10 is 23. 23 plus 14 is 37. So the first difference is not the same. But when we check the second difference, from 6 to 10 we add 4. From 10 to 14 we add 4. So similarly, from 14 to the next number we also add 4. 14 plus 4 is 18. So 37 plus 18 is 55. This is the fifth term. And now we want to find the general form. You see that the second difference is the same. So B is a quadratic sequence. And for a quadratic sequence, the term is an squared plus bn plus c. A is equal to half of the second difference. Half of 4 is 2. And c is t0. To find t0, we need to think of which numbers plus 4 is 6. That is 2. So which number plus 2 equals 7? That number is 5. So t0 is 5 in this case. And to find b, we need to use the first term. The first term is a plus b plus c equals 7. Your a is 2 and your c is 5. So b is equal to 7 minus 2 minus 5 equals 0. So the sequence becomes your A is 2, your C is 5, and your B is 0. So the answer is 2n squared plus 5. C. The sequence is 2 over 27, 3 over 81, 4 over 243, and the fifth term is 5 over 729. For the numerator, we see that each time we need to add 1. 4 plus 1 is 5. So the next time 5 plus 1 is 6 for the numerator. And for the denominator, from 27 to 81 we multiply by 3. 81 times 3 is 243. 243 times 3 is 729. So 729 times 3 equals 2,187. This is the fifth term. Then how do we find the general term? For C, I'll write it here. For the sequence C, I will split it into two different parts. The numerator. The numerator is 2, 3, 4, 5, and 6, and so on. So this sequence has a common difference of 1. And it is a linear sequence. So it has a form a and plus b. Your a will be the common difference, 1. And your b is t0. T0 is the term before this. Which number plus 1 equals 2? That is 1. So the sequence an plus b is n plus 1, 1n plus 1. This is the numerator. And for the denominator, the sequence is 27, 81, 243, 729. We see that the common ratio is 3. Common ratio is 3. So Tn is equal to T1 multiplied by the common ratio to the power of n minus 1. T1 in this case is 27. And the common ratio is 3 to the power of n minus 1. And you know that 27 is 3 cubed times 3 to the power of n minus 1. So we combine these two. 3 plus n minus 1 equals 3 to the power of n plus 2. So this is the denominator. Now we combine the numerator and the denominator. N plus 1 over 3. N plus 1 over 3 to the power of n minus n plus 2. So that's it for question A. Question B. In a sequence, the sum of the first 49 terms is 7,640. So suppose that we have the first term and we add it to the 49th term. The sum of this is 7,644. Then we have one more term. This is the 50 term. And the sum of the first 50 term is 7,975. So we need to find the 50th term. To find the 50th term, we need to subtract the sum of 50 terms, subtract the sum of 49 terms. And the answer is 331. So the answer is 331. Question 7. The frequency table shows the time of each of the 42 athletes in a race. A. Calculate an estimate of the mean time. To find the mean time, we need to find the mid value of each of this. 216 and 219, the middle value should be 217.5. You can say that you add up 216 and 219, then you divide it by 2, so you get 217.5. So this is the middle value of the first interval. Then I multiply this middle value by the frequency 9. That is the first. For the second, 219 plus 224 is 443. 443 divided by 2 is 221.5. Next, 224 plus 234 equals 458. 458 divided by 2 is 229. Next, 234 plus 244 equals 478. 478 divided by 2 is 239. Finally, 244 plus 264 is 508. 508 divided by 2 is 254. So we multiply each mid value by the corresponding frequency. 229 is corresponding to 14. 239 is corresponding to 2. 254 is corresponding to 3. Then we divide everything by the total. There are 42 athletes, so we divide this by 42. And the answer is 226 seconds. B. Complete the histogram to show the information in the frequency table. 2 of the blocks have been drawn for you. So let's find the frequency density. You know the formula of the frequency density is equal to frequency divided by class width. So for the first block, the frequency density is equal to, the frequency is 9 divided by class width, which is 219 subject to 16. So this is 9 divided by 3 equals 3. For the second frequency density, it is 14 divided by 224 minus 219. So this is 14 divided by 5 equals 2.8. For the third frequency density, it is 14 divided by 234 minus 224. So this is 14 divided by 10 equals 1.4. For the fifth frequency density, it is 2 divided by 244 minus 234. So 2 divided by 10 is 0.2. Finally, for the fifth frequency density of the fifth block, it is 3 divided by 264 minus 244. So this is 3 divided by 20. And 3 divided by 20 is 0.15. The 2 blocks have been drawn for you. Those 2 blocks are 3 and 0.15. So now we need to draw the second block, the third block, and the fourth block. This one is 3, this is 0.15. They have been drawn. So now we draw the second block. From 219, here it is, to 224, this one. And the height of the block is 2.8, this one. For the third block, from 234 to 224, this is 224 to 234. And the height of this block is 1.4. 1.4, here we go. The height of this block is 1.4. This is 2.8. And the last block is from 234 to 244. And the height of this is 0.2. 0.2. And that's it for question 6. Question 8. The diagram shows a solid formed by joining 2 hemispheres and a cylinder. The radius of the large hemisphere is 5.4 centimeters. The radius of the small hemisphere and the radius of the cylinder are both 3.6 centimeters. The height of the cylinder is 6.5 centimeters. Show that the volume of the solid is 692 centimeter cubed, correct to the nearest cubic centimeter. The volume of the sphere is 4/3 pi r cubed. So I will split this into 3 parts. The volume of the hemisphere here, it is a half of 4/3 pi r cubed. The radius is 3.6. For this one, the volume is base area times the height. So base area is pi r squared. The radius is 3.6 times the height. The height is 6.5. So that is the second volume. And the volume of this hemisphere is also 1/2 of 4/3 pi r cubed. In this case, the radius is 5.4. So now we add up these three together to find the volume of the solid. The volume of solid is 1/2 times 4/3 pi 3.6 cubed plus pi 3.6 squared times 6.5 plus 1/2 of 4/3 pi 5.4 cubed. Remember, the volume of the sphere is 4/3 pi r cubed. So if you want the hemisphere, you need to divide it by 2. And the answer for this is 692.2. And if we round it to the nearest cubic centimeter, then it is 692 cubic centimeters to the nearest cubic centimeters. Second question, a mathematically similar solid is made of silver. In this solid, the cylinder has radius 0.6 centimeters, and 1 cubic centimeter of silver has a mass of 10.49 grams. Calculate the total mass of this silver solid. So first, we see that the volume of the first solid to the volume of the second solid is equal to the cube of the ratio of their radius. The radius of the first to the radius of the second. The volume of the first solid is 692, and the volume of the second solid is what we want to find. The radius of the first solid, the cylinder, the radius of this cylinder is 3.6. The radius of the cylinder is 3.6 centimeters. So this is 3.6 over, and the radius of the second solid is 0.6 centimeters. So the cube of this means 3.6 divided by 0.6 is 6. So this is 6 cubed equals 216. So if you want to find the volume of the second solid, you need to divide 692 by 216, which is 3.20 centimeter cubed. And we know that 1 cubic centimeter has a mass of 10.49 grams. So if the volume is 3.2 centimeter cubed, then it is how many grams? To find the mass of this, we will need to multiply 3.20 by 10.49. And then we divide it by 1. So the answer is 33.6 grams. B. AOB is a sector of a circle center O. AO equals 10 centimeters and the sector angle is 216 degrees. Calculate the length of the arc of this sector, which means we need to find this length. The formula for that is theta over 360 times the circumference of circle, which is 2 pi r. In this case, the angle is 216 over 360 multiplied by 2 pi, and the radius is 10. So it's 12 pi. Notice that we need to keep the answer as a multiple of pi, so we don't convert it to a decimal. Second question, a cone is made from this sector by joining OA and OB together. So if I join OA and OB together, I will get a cone like this. I don't know the radius of this cone, but we know that the slant height of this cone is actually the length of OA, the radius of the sector. So the slant height is 10 centimeters. And we don't know the perpendicular height. We just know the slant height. That is 10 centimeters. And we also know that the length of the arc in the sector is actually the circumference of the base of the cone. They are the same. So the circumference is 2 pi r is the same as the arc of the sector, so it is 12 pi. We use this answer, 12 pi. So we can cancel pi and pi together. Then 2r equals 12 and r is equal to 6 centimeters. So now we know the radius is 6 centimeters, and we also know the slant height is 10 centimeters. Then we can find the height, the perpendicular height, using Pythagoras theorem. L squared minus r squared, which is 10 squared minus 6 squared. 100 minus 36 is root 64 equals 8 centimeters. And now if we know the height and the radius, we can find the volume of the cone. The volume is 1/3 pi r squared times height, which is 1/3 of pi 6 squared times 8 equals 302 cubic centimeters. Question 9. Given the three functions f of x, g of x, and h of x, A. Find f of 0. We just substitute 0 into the function 3 times 0 plus 1, multiplied by 0 plus 5, multiplied by 0 minus 4. So it is 1 times 5 times negative 4 equals negative 20. Second question. Find the inverse of g of x. Let's rewrite g of x, y equals 2x minus 3. To find the inverse, we need to change y to x, and we change x to y. So x equals 2y minus 3. And now we need to make y the subject by adding 3 to both sides. Then we also divide both sides by 2 to find y. And this y will be the inverse of g of x. So the answer is x plus 3 over 2. Number 3. Find g of h of 2. First, h of 2 means 4 to the power of 2 times 2 minus 1. We substitute into h of x. So this is 4 times 4 minus 1, which is 4 to the power of 3, equals 64. Then g h of 2 means g of 64. Now we substitute 64 into g of x. 2 times x minus 3 is 125. B. G of 2x equals 7. Find the value of x. You know that g of x is 2x minus 3. Gx is 2x minus 3. So g of 2x will be 2 times 2x minus 3. And this one is equal to 7. 2 times 2x is 4x minus 3 equals 7. To find x, we add 3 to both sides. And then to find the value of x, we divide both sides by 4. So x equals 2.5. C. Simplify g of x squared plus g squared plus 1. G of x squared is equal to 2 multiplied by x squared minus 3. G of x means 2 multiplied by 2x minus 3 minus 3. So this is 4x minus 6 minus 3 equals 4x minus 9. And then we combine these two with 1 together. So g of x squared plus gx plus 1 is equal to 2x squared minus 3 plus 4x minus 9 plus 1. So it is equal to 2x squared plus 4x. You know, minus 3 minus 9 is minus 12. Minus 12 plus 1 is minus 11. D. Find the inverse of h of 16. First, we see that the function h of x is 4 to the power of 2x minus 1. So I will write y equals 4 to the power of 2x minus 1. If we want to find the inverse of this function, we need to change y to x, and we change x to y. And now we don't really need to make y the subject, we just want to find the value of y. And we see that in this case, x is 16, so I'll substitute 16 into this. 16 is 4 squared. So 4 squared equals 4 to the power of 2y minus 1. Now we see that the base are the same. So 2y minus 1 should be the same as 2. To find the value of y, we add 1 to both sides. Equals 3. And to find the value of y, we divide both sides by 2. So y is 1.5. And this means the inverse of h of 16 is 1.5. 1.5 is the final answer. E. F of x equals 3x plus 1 times x plus 5 times x minus 4. We find the value of a, b, c, and d. This is easy. We just need to expand the brackets. 3x plus 1 times x plus 5 times x minus 4. So 3x times x is 3x squared. 3x times 5 is 15x. 1 times x is x. 1 times 5 is 5. X minus 4. Now we simplify this into 3x squared. 15x plus x is 16x times x minus 4. Now 3x squared times x is 3x cubed. 3x squared times negative 4 is negative 12x squared. 16x times x is 16x squared. 16x times 4 is negative 64x. 5 times x and 5 times negative 4. So now we need to simplify this. 3x cubed minus 12 plus 16 is positive 4. 4x squared. Negative 64 plus 5 is negative 59 minus 20. This one is equal to ax cubed plus bx squared plus cx plus d. So a is 3, b is 4, c is negative 59, and d is negative 20. Question 10. ABC is a triangle. B is the point 1, negative 10. A is the point 4, 14. And the vector CA is negative 11, 8. 1. Find the coordinates of C. You know, the vector CA means XA minus XC, YA minus YC. So, XA is 4 and YA is 14. So 4 minus XC, and this is 14 minus YC. This means 4 minus XC is equal to negative 11. And 14 minus YC is 8. So XC is equal to 4 plus 11 equals 15. And YC is 14 minus 8 equals 6. So the coordinate of C is 15, 6. Second question, find the vector BA. This one is equal to XA minus XB, YA minus YB. XA is 4, XB is 1, YA is 14, YB is negative 10. So 4 minus 1 is 3. 14 minus negative 10 means 14 plus 10 equals 24. Number 3, find the magnitude of the vector AC. This one is equal to the square root of negative 11 squared plus 8 squared, because this is the vector CA. And the answer for this is 13.6. B. OMN is a triangle. Vector OM equals A, and vector ON equals B. R is the point on MN such that MR to RN is 3 to 2. ORT is a straight line. 1. Show that OR equals 2/5 of A plus 3/5 of B. So, to find the vector OR, we can split it into vector OM plus vector MR. Vector OM is A already. So we need to find the vector MR. MR to RN is 3 to 2, which means the vector MR is 3/5 of the vector MN. And the vector MN is actually the vector MO plus the vector ON. So A plus 3/5. The vector MO is the inverse of OM. The inverse of OM plus the vector ON. So we substitute everything into this. OM is A and ON is B. So now let's expand the brackets. A minus 3/5 of A plus 3/5 of B. A minus 3/5 of A is 2/5 of A plus 3/5 of B. Second question, and the vector NT is for A plus KB. Vector NT, this one, is equal to 4A plus KB. 4A plus KB. And vector OT is C times OR. Vector OT, this green vector, it is C times vector OR. And from question 1, you know that the vector OR is 2/5 of A plus 3/5 of B. And we also know that the vector ON is B. So we will use the relationship between these three vectors. Vector OT equals vector ON plus vector ONT. So we'll write down this relationship. OT equals vector ON plus vector NT. So let's talk about each of them. The vector OT is C multiplied by vector OR. And from question A, vector OR is 2/5 of A plus 3/5 of B. Vector ON. The vector ON is actually B. Now, the vector NT. In question 2, you know that vector NT is for A plus KB. Now we substitute everything into this. So vector OT is C multiplied by 2/5 of A plus 3/5 of B. Vector ON is B. Vector NT is 4A plus KB. And now we expand this brackets. 2/5 of CA plus 3/5 of CB equals 4A plus B plus KB. B is the common factor, and we have 1 plus K left. So if these two are equal, then we know that 2/5 of CA must be equal to A for A, and 3/5 of CB is equal to 1 plus K multiplied by B. Now we cancel A, B. So what is left? 2/5 of C equals 4, and 3/5 of C equals 1 plus K. From the first equation, 2/5 of C equals 4, so C is equal to 4 divided by 2/5 equals 10. And for the second equation, 3/5 of C means 3/5 of 10 equals 1 plus K. So K is equal to 3/5 of 10 is 6. 6 minus 1 is 5. So K equals 5. K is 5 and C is 10. This is the final answer. Question B. Find the vector MT. Look at the diagram. The vector MT is equal to vector MO plus OT. MT is MO plus OT. MO is the inverse of A, and the vector OT is C multiplied by 2/5 of A plus 3/5 of B. And you know that the value of C is 10, so this is 2/5 of A plus 3/5 of B. Now we expand the brackets. This is negative A plus 10 times 2/5 is 4A, and 10 times 3/5 is 6. So negative A plus 4A is 3A plus 6B. So the answer is 3A plus 6B. Question 11. Differentiate x cubed minus 4x squared minus 3x. The derivative of x cubed is 3x squared. The derivative of x squared is 2x. And the derivative of 3x is 3. So the answer is 3x squared. 4 times 2 is 8 minus 3. B. A curve has equation y equals x cubed minus 4x squared minus 3x. Work out the coordinates of the two stationary points. To find the stationary points, we will let this to be 0, which means 3x squared minus 8x minus 3 equals 0. You can solve this equation using the quadratic formula, or you can factorize it. So if you use the quadratic formula, then it is negative b plus or minus the square root of b squared minus 4ac over 2a, which is negative of negative 8 plus or minus the square root of negative 8 squared minus 4 times 3 times negative 3 over 2 times 3. So x is equal to 3 or x is equal to negative 1/3. If x is equal to 3, then y is equal to 3 cubed minus 4 times 3 squared minus 3 times 3, and y is equal to negative 18. For the second case, y is equal to negative 1/3 cubed minus 4 times negative 1/3 squared minus 3 times negative 1/3. So the answer for this is 14 over 27. So let's write down the answer. X is 3, then y is negative 18. If x is negative 3, y is 14 over 27. C. Determine whether each stationary point is a maximum or a minimum. Show on your working. So in this case, we see that x cubed minus 4x squared minus 3x. And you know that for a graph of ax cubed plus bx squared plus cx plus d, if your a is positive, then the graph will be like this. If your a is negative, then the graph will be like this. In this case, we see that your a is 1 and 1 is positive. So the graph should be like this. And we have two stationary points. The left point is a smaller value of x, which is negative 1/3, 14 over 27. And the right point should be 3 and negative 18. So we say that the maximum point is negative 1/3, 14 over 27. And the minimum point is 3, negative 18. And that's it. This is the end of the test.